Hello, this is Pete Cacciopi. I'm Chief Scientist at Opalytics, and this video is the third in the series of tutorial videos showing how to combine the OPL programming language with Python by using the ticdat package. So here we are at the ticdat home repository page on GitHub. This is the address up here, GitHub, Opalytics, Opalytics-ticdat. Let's drill down into the example we're going to be showing today, which is a constraint programming example. So it's here at examples, expert section, OPL, CP jobs. So we'll quickly review. This is similar to before, so I'm going to be moving fairly quickly, similar to the previous example we did with mixed integer programming. So again, we have this mod file here, jobs.mod. You can see, you can use this address, which resolves to this example page in the IBM Center. And similar to before, starting here with this dvar line going down through the end, this is all the math section that's rendering the core mathematics of the constraint programming model. And that's all copied over faithfully starting right here at line 35, right? This core mathematics section. And then in this mod file, the beginning section here, the initialization section, and the ticdat output section are just simple boilerplate codes that you need to add to the .mod file in order to connect it to the results to the way that the Python jobs.py file works. So again, there's a little bit of boilerplate you need to use to connect Python to constraint programming via ticdat, but it's fairly simple. We go back over here, show the jobs.py file that you would have to write. Similar to before, we have to define the input schema and the solution schema. Again, this block here where we're creating data integrity rules is technically optional, but it makes your code a lot safer and easier to debug. If you've ever tried to debug bad data being passed to OPL, you probably have been a little bit frustrated. So if you pass bad data to this jobs.mod combined engine, you will get a nice clean error message here if you're running from the command line. And if you're running in the Opalytics Cloud Platform over here, you'll get an even more clean, prettier graphical feedback focusing on where the data integrity errors are. Okay, so since I've already teased you with the Opalytics Cloud Platform, let's go over here and let's load up this jobs.py, jobs.mod engine as an instant app. So let's go to our App Store. As before, we're going to create an instant app. It's an OPL Cplex. We're going to call it Jobs. Let's give it a nice Jobs icon. And let's upload the two files, jobs.py and jobs.mod. And now we save the app and nice feedback saying that it was created. So let's go back over here to projects, go into our demo project. Let's just upload a file straight away. Again, similar to before, if I wanted to build the data set by hand, I could do so. And the data integrity rules would make it easier for me to build the data by hand because the platform already knows the schema of this app that we created. But let's jump straight to a file upload. So this is jobs data.xlsx, and let's upload that access file, that Excel file, and we're going to set it to be, here is our friend jobs, the app that we just created. And all the data integrity rules are valid. So let's run the solution. And it solved successfully. In this case, we didn't create a KPI table, so we just have the act solution report and the act as date solution report. So the act solution report just gives you sort of simple numbers for starting and ending. Now, if you jump back over here to jobs.py, this act solution report was created directly by reading it directly from the jobs.mod file. So in other words, it was populated right here in the mod file section, right here, slm_act. And if you look down here, you can see we also populated another report table as dates. And in this case, we formatted the starting and the ending as times, and when we did as date times, and when we did that, we treated those numbers that the constraint programming model was giving us as minutes offset from the current date time. So that's what this block of code here does. And the end result here is that when we populate the act as dates report table with actual dates instead of simple numbers, and as a result, here it is the same data except with numbers. And as a result of that, I go over to here and visualize it. By default, the cloud platform recognizes this schema as being one that's appropriate for a Gantt chart. And so a Gantt chart gets loaded. And here we have this is a pretty intuitive Gantt chart. If you study it, you can see that these processes, that there is never more than 3 processes at a time, which is exactly what you would expect, because if you look at the constraint programming model and the data that we passed it, there are only 3 machines. So it doesn't make any sense for there to be more than 3 processes operating at a time. And of course, there are some instances where there's only 2 processes at a time, and that's also makes sense because it's hard to perfectly fill up any sort of knapsack. And it's also the case that the way we formulated the model, the jobs are all hard-coded to specific machines. But at any rate, this Gantt chart, makes it nicely clear how things are being sequenced properly. You can see you always get the proper sequences. First you have to do load A and then unload 1, then process 1, load 1, unload 2, process 2, load 2, unload S at the very end. Right? So this is the same pattern, the same color pattern appears for each of the jobs. So it makes it very easy to validate that we have an optimal solution, or excuse me, a feasible solution. Okay, thanks for your attention, and I hope you will join me on future Opalytics videos.